Hey guys, so I'm in New York City right now, and I just wanted to make sure that you knew that I was recording your lesson for day 3, okay? You will have a sub today. Please make sure that you are working, even though you have a sub, and that you understand that the homework assignment is there that you see online right now on the screen. So you see the warm up 5.2 SAT. We have notes. Guys, there's a lot of notes. So although it was bad timing as far as me to miss due to my birthday and go to New York City, I'm going to tell you that we are not going to fall behind. And I'm going to be very thorough in these videos as far as, or in this video that you're going to see all these example problems concerning day 3, okay? The only thing that I will not do is number 4, where it says intro to the box project. I will introduce that whenever I come back on day 4. I just want to make sure that I'm there for questions on that since that's your performance task. Okay, but you see right there online, it says 84XL 793, 12, 18, and 23. That is half a homework grade. And then if you clicked on that mixed factoring worksheet, that will actually also be homework, and that's a full homework grade, okay? And then that's it. I mean, SAT notes, and then this cutty corners boxes. I'm going to show you visually what's happening there, but nonetheless, the intro to the box project I will cover whenever I come back. All right, so let's get started. All right, so if you were to click open those links, you would see the following pages. You would see this one right here for the warm-ups. And since I'm not there, you guys are basically just going to watch the video as if I was there. And then kind of work the problems with me as you go through. I'll try to pace it accordingly. This is the second link. So on the calendar where it says notes, these are the notes, and there's like 7 pages. There's a lot of them there. And then the cutty corners activity, and then the solution to it, okay? So if you click on those 4 links, they are right 1, 2, 3, and 4, and you'll be able to see those. If you want to, that'll be easier for you to see as far as them being zoomed in and whatnot. All right, so let's go to begin. Solving polynomial equations using factors, okay? And the quality questions, basically your big overall questions are, which types of real life situations would be represented with polynomial functions? And we have looked at how to maximize the volume of a prism. How could you minimize the volume? Okay, so let's go ahead and begin. So I actually have an onboard whiteboard for my daughter that I'm going to use as far as to go through these example problems. Okay, so again, these are in your notes. These are page or paper notes. There's no paper for me to pass out to you on these. The only thing that I would have passed out had I been there today is the activity for the cutting corners for the box project. Okay, and it isn't necessary for you to do that. I will show you visually what that all entails here in just a bit. But let's go to begin because it's a lot of notes. Okay. So it says which inequality is equivalent to what you have here. So this is an SAT warm-up question. Okay. If you want to know equivalent, you're just going to basically solve for x. So I'm going to move over this -2 over to the left side, and I'm going to move over this 4 to the right side. So I'm basically subtracting 4 from both sides of this inequality, and I'm also adding 2x to both sides. Okay, so these 4's would cancel to 0, and -5 plus 2, you'd have -3x. And then whenever you move this positive 2x over, it would be 7 minus 4. So you're going to have a positive 3. Nothing has happened to the inequality sign, but because you're trying to get x by itself, the next step would be to divide both sides by -3, which then x would be all by itself as a positive, but then you must flip this inequality because you divided by a negative, and then you'd get the positive 3 over a -3, which in fact would be a -1. So x is greater than or equal to -1, which D would be the answer there. Okay, let's look at number 2. So number 2 has a line with slopes and a point, and it says if negative 3p is another point on the line, what is the value of p? So the big thing on this is that with y equals mx plus b, we have a line that could, this one says it goes through 4, negative 3, 1, 2, 3, 4, 1, 2, and 3. So that's where this point is at here. And if it has a slope of negative 3, okay, let me box that, it's going to be down 3 over 1. So down 3 to the right 1. And the line looks something like that, okay? So the slope is negative 3. And the point here is 4, negative 3. And what this is asking for, what would p equal if negative 3p was also on the point? Okay, so it could be anywhere on this line, like the other point could be here, wherever it's at. But this one says specifically at negative 3, and then all the way up here. Because the line would continue to extend to the left, going through this point. Okay, so it's asking what is p? Otherwise, what is this y value that would hit the y-axis, since this is negative 3 for the x and p for the y. So the way you're going to do this is you're going to set up an equation using the slope formula. So y2 minus y1 over x2 minus x1, and it's equal to m. So it'd be negative 3 is equal to, no, it doesn't matter as long as whatever order you establish, you use it the same. So I'll say p minus a negative 3. All I did was subtract these y values from each other. And then I'll use this one first, since I used this p. I'll put negative 3 minus the other x value. Because remember, I'm subtracting the x's. So minus 4. So p minus a negative is the same as p plus 3. And negative 3, oops, I don't know why that needed to sync. Negative 3 minus 4 would be a negative 7. And all we have to do is solve for this. So if I want to get rid of this negative 7 on the bottom, I'm going to multiply both sides by negative 7. So negative 7 times negative 3 would equal to a positive 21. These cancel to a positive 1, so that I'm just left with the numerator of p plus 3. When I subtract 3 over, p would equal 18. Okay. And last but not least, we're going to do number 3. And 3 has a lot to do with kind of what we're working with in this unit for sure. It says find all solutions of the following quadratic. So if it's set equal to 0, and what we've learned so far in the past couple units, as far as factoring goes, or past couple days and last unit, is I'm going to try to see if I can first GCF this out, which I can't because not all of them have the same kind of term. Like this one's missing an x, and this one's missing like a 3. Okay, so you really can't GCF something out of this trinomial. So we're going to go straight to the factoring process. Remember, they will both multiply, the first terms that is, will multiply to get this x squared, and then these second two will multiply to get a negative 3. So you're thinking of 3 and 1. One of them has to be negative in order to make that negative work here. So if I did that, I would have to make this one a positive in order to make this work. Okay, so that when you multiply negative 3 with a positive 1, you would get a negative 3. Because if I put negative 1 here, it would become negative 3 times negative 1 is a positive 3, and that didn't work. Okay, so we have a negative 3, we have a positive 1. And the big thing on this example is that you're going to see that if you were to distribute this inside and outside piece, I get a negative 3x and a positive x. And this would result in a negative 2x. That's nowhere near to this 6 that we need. Okay? So with that being said, some of you might think, well, maybe if the 1 was negative and the 3 was positive, it wouldn't have worked either, because I would have a positive 3x and a negative 1x, which would have been a positive 2x. Okay, so you see, it's the same number, only one is positive and one is negative. Since the factors of 3 are only 1 and 3, there's nothing else that we're going to be able to do so that this inside and outside piece would add to 6. So what we learned last unit is we're going to have to do the quadratic formula. okay? So when they don't work out to give you that b value, which in this case is that positive 6, we definitely have to use the quadratic formula. So we'll say x is equal to a negative b, since this was b, a, and negative 3 is c. It'd be negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. So this right here is going to be what I have as far as my quadratic formula setup. Now I'm just going to work on trying to simplify it out and see what I get as far as an answer goes. Okay, so we have negative 6 plus or minus, and this is a negative 4, positive 1, negative 3, which is a positive 12. So we have 6 squared is 36 plus 12. All I did was work with what's underneath the square root, all over 2. Okay, so 36 plus 12 is going to be 48. So we have 48 underneath the radical symbol, and it's over 2. So now we're going to try to simplify what is this root 48, because I don't see any root 48s in my answer. Okay, so let's make a little bit of room right here, and let's try to simplify this radical out so we can reduce. Okay, so the square root of 48. Again, I know it's been a while since we've done this, but think of 2 squared, think of 3 squared, whoops, think of 4 squared. So we're looking at 16, 9, 4. You're trying to divide this thing by something big, okay? In this case, the 16 does work, because 16 times 3 is 48. Okay, all I've done is change 48 to look like 16 times 3. And the reason why I did that is because I know I can square root this 16 out as a 4, and everything else stays the same. So it's going to be 4 root 3 is what all of this square root of 48 changes into, okay? The rest of this stuff, it's still the same. You have negative 6 plus or minus that over 2, and now you can reduce this, okay? So you can break this up because it's adding and subtracting with a common denominator of 2 so that it would look like this, okay? So then this would reduce to a negative 3, plus or minus, this would reduce to 2, and it's just the coefficient up front, and you would get something that looks like this. There's 2 answers. There's negative 3 plus 2 root 3, which is what you see right here, and then also negative 3 minus 2 root 3, which is what you see right there, okay? So C would be the answer there. All right, so now let's go ahead and move on to our notes. Okay, this is going to be a long video because there's a lot involved today, okay? Again, I'm going to talk through all the steps and processes, but you already noticed that a lot of them are already pre-written and filled out. I'm just going to kind of scaffold and talk you, navigate through so that you're understanding as if we did it without it being all pre-filled. All right. What are the real and the imaginary solutions? The real solutions are, again, when we just did that example problem, b squared minus 4ac. The big part is underneath the radical symbol. If I have a positive number that results from all this b squared minus 4ac, I will have a real answer over here. But underneath the radical, if it's a negative, then it's going to come out with imaginary i's and whatnot. Because remember, we can't take the square root of a negative 1, because we learned last unit that that equals I. And we also learned that if I squared both sides, that negative 1 is equal to I squared, okay? So that's going to go into play right here. And it's been a minute since we've done it, but I need to make sure to remind you, it's all about the discriminant test to see, are we going to have real or imaginary solutions? And remember that it's only what this matters. This is what we're testing. We're trying to see, is it equal to 0? Is this value negative? Or is it positive? Okay? This negative will be the imaginary solutions. These will be the real. Okay? This one's going to have like 2 answers that are the same number, and these would have 2 answers that are different numbers. Okay? So let's go ahead and go to work this out. So if I were to subtract the 3x over as you see they did here, first step is to set it equal to 0. Okay. Now the next step that they did is that they GCF'd out an x. So they pulled out an x out of everything and they put it right up front. So that what was left over was 2x squared minus 5x minus 3. Now they went ahead and factored these out to where these two right here and here would multiply to give you 2x squared. And then you ask yourself, what two things would multiply to give me negative 3? Well, that's either a positive or a negative 1 with a positive or a negative 3. You might have to do a little bit of playing around, trial and erroring to see where should the 3 go. Should it go over here with the 2, or should the 1 go over here with the 2? And then the second thing is, which one should be positive, which one should be negative? Well, from the outside and inside, you see the outside gave us a negative 6x. Okay? And then the inside gave us a positive x. And when we combine those, we sure enough get this negative 5 that we needed. So these three are our factors. Okay? You saw that they set x equal to 0 all by itself. This next factor, they set this equal to 0. And this last factor, they set x minus 3 equal to 0. Because when you solve for x, you add 3 to both sides. Here's your 0, your x-intercept, your solution, your answer, all that stuff that we were talking about from before. Here is subtracting the 1 over so that you would have 2x is equal to a negative 1. And then when you divide by 2, you get a negative 1/2. And then x is equal to 0 because that doesn't have to solve for anything. It's already set equal to 0 all by itself. So look, here we go. The third degree polynomial, that means it was like x cubed, okay, something cubed, shows that there will be 3 answers. Okay, that's very important. If it was x to the 6th, there'd be 6 answers, okay? So this shows that there's going to be 3 answers. And right here, you see that they're all real. These are all real answers, okay? And what we could do, I know I kind of skipped over it just a little bit, is verify that with the discriminant test. In fact, I would do the discriminant test first to see which one of these answers are you going to be getting. So if I go back to this spot right here in the standard quadratic form, which in this case I know it's a cubed function, I can't do it at this step. I need to do it here. You can only do it when it's quadratic because it's all about x squared as far as the parabola goes, as far as the quadratic function. We learned that last unit. This standard quadratic of ax squared plus bx plus c is equal to 0. This is when we use the discriminant test. So we have to wait to the second step to be able to see it's going to be in quadratic, and just for that little piece, I'm going to do the discriminant. A is 2, B is negative 5, and C is negative 3. So if I did this discriminant test of B, be careful with parentheses, B squared minus 4AC, we would have negative 5 times negative 5 is a positive 25. And just multiply these three numbers together. Negative 3, negative 4, 2. So I have a positive 12 times 2 is a positive. Okay, negative times a negative is a positive. If there were 3 negatives, then it would become a negative. So we're going to add 24, and this is way, way positive. Okay, so it is definitely going to be this one right here, which those two solutions actually came right here as negative 1 and a positive 3. This step right here verified that you would have 2 real solutions. That x that was all by itself over here after we GCF'd, that was the third one right there. All right, so I was very thorough on that first one. I'm going to get a little bit faster as far as these other ones go, since you know the premise now. Here we go. What are the real and imaginary solutions for the polynomial? Notice what they did. I have 4, 3, and 2. They put them in descending order as far as their powers go. The degree of 4, the degree of 3, the degree of 2. They set it equal to 0. Here is where you would try to see as far as, can I simplify this, okay, to where the a coefficient is 1. So what I did is I basically divided both sides. I divided all this by 3, and I divided 0 by 3. Well, 0 divided by 3, that's still 0. But this is like, this became 1, negative 6 over 3 became negative 2, and positive 12 over positive, actually a negative, let me see that real quick. So dividing out by a 3, this would change this. This should be a positive right here. I don't know why that's a negative. Let me make sure. Just subtract it over. This is positive. Yeah, that should be a positive. That's weird. Okay, but anyway, when we would divide it by 3, this would be the equation that I would have. Okay, and then from here, you could further divide it by an x squared. Okay, so if you take out an x squared from this piece, it's like divided by x squared, divided by x squared, and divided by x squared, this would reduce to the following. X squared, whoops, let me change color. X to the 4th over x squared, 2 are left on the top. X cubed over x squared, 1 is left. And then x squared over x squared, you have a positive 4. So see, there's that positive. I don't know why this one wasn't positive in the textbook, but textbooks are wrong sometimes, believe it or not. All right, so x squared minus 2x plus 4 is what we ended up factoring, okay? So what I probably would do here is, because we're looking for the solutions, is solve this for the discriminant test. So negative b. So, oh my bad, I was going to do the quadratic formula. I meant to just do the discriminant test, which is that, okay? So b squared minus 4, the new a, which is 1, the new c, which is positive 4. Okay, here we go. Negative 4, 1, and positive 4 is a negative 16. Negative 2 squared, again, it's just like negative 2 times negative 2. You got to be careful with that parentheses right there, and it would become a positive. So positive 4 minus 16 is obviously a negative number, so we know we're going to have 2 imaginary solutions for that piece. Okay, so let me color coordinate this a little bit. So because of the fact that this is negative right here, we're going to have 2 imaginary solutions for this and 1 real solution for that. Okay, so x squared is equal to 0. It's like saying, hey, square root both sides to get x by itself. And the square root of 0, it's 0. Okay, so far, because this is x squared, multiplicity of 2, we talked about this, it's like a double root. We don't have to write it twice, but if I did, I would list it out like this. Okay, so there should be 2 more roots because of that number 2 right there that says there's 2 more answers in this polynomial. Okay, so this is negative. It's a negative, what, 12? So if I were to do the quadratic formula, and this is why this is helpful to do the discriminant test, we know this red piece right here, we already solved it. It's a negative 12. Okay, the rest of this would be negative b, so negative b plus or minus the square root all over 2 times 1, which is a. Okay, so now this will become a positive 4. The bottom is 2. It's plus or minus the negative root 12. And now I'm ready to simplify this out. Negative root 12 will simplify out to a negative 4 and 3. So that I have the 4 right here will come out as a 2. This negative 1 will come out as an I. And the 3, it stays inside. And you're left with this. And then finally, we can solve this out as far as reducing it. So 4 and 2 would reduce to 2. and 2 over that same denominator, because again, you can write this as two separate ones. You need to understand that, but you don't have to show this step because it's all over 2. You don't have to show it if you can see it. So 4 divided by 2 is 2, plus or minus I root 3. So that would be like me writing out 2 plus I root 3 is an answer, and 2 minus I root 3 is the other answer. 4 answers, but again, this double root, you don't have to write it twice. I could have chosen just to write it one time and still been good. And those would be my 3 answers. But again, this is a double root. We basically count it twice. Okay, so let's see. So what are the real and imaginary solutions? And these right here would be the imaginary solutions. And these would be, that would be the real solution piece, okay? So let's go ahead and keep going. It's a lot, guys, and I do apologize that I wasn't able to be there, but I could not pass up New York for your birthday. All right, so what are the real imaginary solutions for this polynomial? Okay, this might have been the answer to what we just did. 6x cubed, 12x squared, and 3x to the 4th. Oh, okay. So whenever I set this up, I realized just now, and probably some of you, especially you bright ones as far as seeing it very quickly, this should have not been a 4. This right here should have been a 2. Okay, I don't know why I wrote 4. So all of this would have changed. This 2 would have ended up becoming 1. Okay, so sorry about that mistake. So my final answer is 1 plus, whoops, I root 3. And then the other one is 1 minus I root 3. And those are those imaginary pieces. Okay, so 1 here, 1 there. And sure enough, this is just the key to the one up there. Showed all the steps that we did to get the same answer here. And notice that they just wrote this one time. There's one solution. 1 plus I cubed is the second solution. 1 minus I cubed. 1 plus I root 3 and 1 minus I root 3 would be the third and fourth solution. This 0, which is a double root, is the first and second. Okay. All right, so let's keep going. What are the real and imaginary solutions of this? So what's good about this is the fact that it's already factored out for us. When we are looking for solutions, you want to set it equal to 0, you want to factor, and then you want to find what is x. So because this is already factored for us, that's a lot of work already done. We just have to look at between multiplication. Let's set each piece that's being multiplied equal to 0. So there's the first one, okay? And here is the second one. Now, if I solve this one out, I'm going to add 1 to both sides and then square root. Here's the kicker. When you square root, anytime this power, this is huge, is an even number, and it's set up like x squared equals a number, x squared, or x to the 4th equals a number, x to the 6th. Anytime this number is even, you have to do a plus or minus on the right side. Okay, and the reason why is x squared is equal to a positive 1. That means its zeros or its zeros or its roots can either be 1 or negative 1. Because if I were to plug them back here, let's say that I plugged in 1, it'd be 1 squared is equal to 1. That works out. Let's say I were to test this by plugging it back into x squared. I'd have negative 1 squared. Does it equal this one? Sure enough, it does, because -1 squared is -1 times -1. Okay? So when you have two negatives, they make a positive. And because of that, you know that if you have this even power, it would be a plus or minus. Huge, 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 because so many people forget this plus and minus. Let's come over here. So if I subtract, I'm about to take the square root of a negative. Okay, so I know it's going to be x is equal to still that plus or minus because this is even. But the difference here is that you have a -4 inside. Okay, that 4 will come out as a 2, and this -1 will come out as an I. So it's like, whoops, that's not I, that's 21. So 2i would come out from the square root, and everything else in blue is still there. So we have x is equal to a positive, and you can write it like this or like this, either one. But notice how we have 1, 2, 3, 4 answers, because x squared and x squared, the biggest that they would get is x4 if they were to distribute it all together. And you can see your solutions are right here. Now, you notice from the work they did the quadratic formula. I don't think it's necessary, as long as you can remember when you have a step that looks like this, x to the power of an even number is equal to a number. When you square root, just remember that it's the plus and minus. That's what it's accounting for over here, okay? Just big on that if you choose not to do the quadratic formula. To me, I think it's just too much work to do the quadratic formula. All right, here we go. What are the real or imaginary solutions for the following? Notice what we always do. We always set it equal to 0. So they move the 4 by subtracting it. It's in descending degree order. This right here is a little bit weird as far as what they did. People freak out when this is not 3 or 2. Okay? And all they did here is they're saying anywhere that you see an x squared, just let it be a. So this x to the fourth right here, it's like saying x squared is a. And what we're going to do is we're going to square a. So it's like if this is a and I square it, this would be x to the fourth. Okay? It's like they're substituting it, and they're going to change the variable just so that it's easier to factor, because people can see a squared and they can think it's x squared. It's easy to factor. But if you see x to the fourth, people freak out a little bit, okay? So again, we said x squared was a. Notice how this is easy to see that it became a. This one's just a little bit more we got to work with. If this said x to the sixth, this right here would be a cubed, because a, put it here, would look like this. And power raised to a power, we multiply. And that's if it looked like x to the sixth. It didn't. I just gave you an example. So imagine that we're just here, and these two multiply to give you a squared. These two multiply to give you a -4, and sure enough, the inside's -4, +1. Got to be fast on this with your number sense. Will give you a -3. Set each one of these equal to 0 and solve for a. It'd be like saying, or you can replace and substitute it back with x squared. Again, a lot of you are going to do things differently. Some of you might say a minus 4 is equal to 0, so that a is equal to 4, and then you would replace this to get over here what these guys got. Either way, it's going to be fine, okay? However you set it up, you're still going to get the same solution. For instance, let me finish this off here. If a is 4, and I replaced it back, x squared is 4, what we learned on the last one is that this is going to have a plus or minus. So x equals a plus or minus square root of 4. Okay, so you got to square root both sides. The x is left, 2 is going to be left here. Okay, so you have x is equal to plus or minus 2, which is right here. Some of you might be different. Some of you might have said, I'm not going to set a minus 4 equal to 0. I'm going to replace x squared first, and then set this equal to 0. okay? And if you do that, you're still going to move the 4 over, and that's when you get to this step here. These steps are going to be the same. Square root both sides, you ended up getting this. Just don't forget the plus and the minus, okay, with any even power. Okay, so however you want to do it, as far as when you replace this x squared back into a, that's fine. But you'll notice here, so this one's taken care of. Let me color coordinate this. This blue right here is going to get me this negative and positive I, which comes from this step. So all these steps go together. So for instance, x squared plus 1 right here. And already when you get x squared by itself and you see a negative happen, all I did was subtract 1 on both sides. Or from both sides. This is going to be the plus or minus square root, okay, of this negative 1. Again, look at what happened. All I did was take the square root. When you do that to both sides, you must put this plus and minus right here. So that this becomes x, this is still plus minus, and this is still negative 1, which comes out as an I. So plus or minus I. And that's what you saw right there. Okay, so you have two imaginary solutions, and then you have the other ones. Oh, one thing real quick. The imaginary solutions will always, they will always come in a pair. Okay, for instance, this one was a positive I or a negative I. The one that we had up here was a negative 2i and a positive 2i. Okay, they will always come in pairs. All right, let's keep going. Real quick though, our answers are right here. And I wanted to show you real quick that you could, if you wanted to, this replacing x squared with a business, you don't have to do it. The way that I showed you as far as one of the very first ways to factor was that number sense interpretation. Check this out. We could say from this step right here, what two terms would multiply to give me x to the fourth? Okay, and you could choose x cubed and x, because when you multiply things with the same base of x, the powers would add. 3 plus 1 would give you 4. Okay, or you could have done the first one to be x and the second one to be cubed. You're still going to get the 4. But remember how we did that factor tree? Like if I factored 4, I'd have 1 and 4, like a rainbow, and then 2 and 2. That's like the center of the rainbow. And I always told you to start from the center and work your way out. So what I like to show students to do for efficiency is to quickly go with that number sense interpretation and go from the inside and work your way out. So those two would multiply to give me x to the fourth. Okay, and then I would say what two numbers would multiply to give me this negative 4. I could put 1 and 4, or I could put 4 and 1. But again, I'm going to work through the middle and work out. When I do these number sense factoring kind of things, I would have x squared plus 2 and x squared minus 2. Okay, and if I were to keep going from here, this one's a little bit different because I got to make sure that this 4 that I create does in fact get my b term. Okay, remember this is very important with number sense interpretation. When I taught you this, I said these two, like 2 times x squared and negative 2 times this x squared, they have to add to get this b term right here. When I mean b term, I'm talking about ax squared plus bx plus c. Okay, this middle term, these have to add to get this negative 3, okay, which in this case was negative 3x squared. That obviously does not happen here. So again, when the center working out doesn't work, then work on the next ones that are outside from the center. which in this case would be the 4 and the 1. So little trial and error here. I told you this unit is hefty. It's an extension from last unit for sure. You'd have a 4 and a 1. So you have a 1 and a 4, which if I add, could give me a 5. If I subtract, give me a 3. That's what I needed. I needed that 3. Now I just have to figure out which one's positive, which one's negative to make the negative 3 happen. Well, negative 4x squared is bigger than a positive 1x squared because when I add, I still want to be negative. So this is what we have all the way down here. So this replacing business, you can definitely skip some confusion and skip some work if you kind of think of it like this number sense factoring goes. All right, so let's keep going. So we have the same question for this factored, this polynomial here. Same steps, okay? I'm going to move this 4 over and set it equal to 0. So we just subtract over from both sides. And this is the x, oops, made a mistake there. This is the x to the 4th minus x, or 3x squared minus 4 that you see right here. Okay, so it's the same exact problem, only this right here, you can do it with graphing. So to check it, you can always graph it, okay? And notice this, that we have this graph from this equation, and the graph only shows that it went in the x-intercept of -2 and +2. And just a reminder, the reason why those are the only two is because these were the real answers. This was the imaginary. Okay? And imaginary, it'll still change directions, it'll still curve or bend, but it never touches the x-axis. Like, we don't know where I is at. You know what I mean? We don't have an I is here or 3i is there and a 4i is, you know what I mean? We don't have that going on as far as the real number line x-axis. But this imaginary solution set, it came from some kind of x squared. Some kind of x squared equal to a negative number. It means, I know there's a lot we're learning in this unit, but that means it's like one change of direction can exist amongst the imaginary. So here I have 3 changes of direction because my original power was 4, my biggest power was 4. So if I subtract 1 from this, it could have 3 changes of direction. But you see, not all changes of direction have to go through the x-axis per se, as far as alternate and whatnot. These two came from the real, and this imaginary piece, change of direction, came from here because it never crossed the x-axis. Okay? All right, so let's continue. All right, so this one is just x to the 4th is equal to 16. Remember last class when I was like, what's the biggest power that you have plus all the extra junk? Well, this one, it doesn't have extra junk per se. If I set it equal to 0, the only extra junk, this is important, that it has is a constant. So if we were to look at this, we could say like f of x, like a graph, is equal to x 4th minus 16. You guys are awesome with transformations. So you know x to the 4th looks like this. So it's like a parabola but with a wider bottom. That's x to the 4th. And if I subtract it, it's like I vertically shifted down 16 units. So that the graph will be way down here at -16. Okay? So if this is the graph, all right, and it's way down here, it looks like it's only going to have 2 real solutions as far as where it crosses that x-axis. Okay? Again, this is if and only if it is a constant. So all this extra junk, I said that it could have more changes of direction if it had a bunch of other x's involved. But if it's just a number, like a constant, okay, It's not necessarily going to have 3 changes of direction. It could just have 1. Okay? So setting this equal to 0, see this substitution of a again? I'll let you read, kind of look at that through the video, pause it wherever you need to, but I'm not going to show the a. I like to go straight for that x to the 4th. Okay? So x to the 4th minus 16 is equal to 0. And this one primarily, something that we've done a while back, is the difference of squares. If I square root this first one, I get that. If I square root this next one, this next term of 16, I get this. And this is called a difference of squares. Because this is negative, this one would be positive, and this one would be negative. See, and real quick, I've now got the multiplication happening to where I can set each piece equal to 0, and then solve for x. Okay, and that's what you see right here. So this difference of squares on the new level, okay, so you had a difference of squares way up here. But once you divide it by one level, or you factor it by one level, on the next one down, it also had another difference of squares, okay? It was right here. So it's like this one can further break up into x plus 2, x minus 2, okay? So that's what this one became. It was a difference of squares, became another difference of squares, and ended up becoming x plus 2 and x minus 2. This other one, after you did the first step of difference of squares to get this x squared plus 4 business, it just stayed as is. Because you can't factor this the way I just showed you with this one. You can't, okay? So like, here we go again. X squared minus 4, if you did difference, which is subtraction of squares, it'd be x, it'd be square root of 4 is 2, 2. This is a negative, so one would be a positive, one would be a negative. That's how we got this piece right here. Okay, but this one in purple, it doesn't, you can't factor the way you did the difference of squares. There's no such thing as a sum of squares, okay? And the reason of it being is, if you try to use this addition symbol, check this out. This is a big learning moment. A lot of people struggle with this in calc. Square root of x, square root of 4. But notice you don't have an x here. It's not like x squared plus 4x plus 4 or x squared plus 20x plus 4. There's no x, there's no b term there. Because the only way to get rid of it would be like this. But that would make this a negative. So that's not possible. And you can't put both of them as positive in order to make this positive happen, because then you have 4x. You would end up having like x squared plus 4x plus 4, which is not what you have right here. Okay, so that's why there's no sum of squares. The biggest way that I can show you, the fastest and easiest way, is that if you looked at this and set it equal to 0 and moved the 4 over, you can't take the square root of a negative. Okay, it'd be x is equal to the plus or minus square root of a negative 4, which would become 2i. These are imaginary solutions. Okay, so when you have something that looks like this, it looks like a sum of squares, this is what it ultimately equals. But if you have something that looks like a difference of squares, you could do this, like x squared minus 4 is equal to 0, like we did on those other examples up top. Move this 4 over without doing the quadratic formula and all that other stuff. I told you there's different ways of factoring. If I took the square root, it would be a plus or minus square root of 4. Okay, and the square root of 4 just simplifies to 2. And that's how you have a plus or minus 2, which there's no i's there. That's where we got these two answers from. Those are the solutions. These are the places where it crossed the x-axis. These are just, furthermore, some are kind of hidden in that change of direction or changes of directions where it never comes back up to cross the x-axis. Okay, so imaginary solutions never cross the x-axis. Real solutions do cross the x-axis. That's why they're called zeros, solutions, x-intercepts, roots. Okay. All right. Let's move on to. And again, you might have to rewind this video. You might have to pause it, whatever it is that you need to. We are almost done, but make sure that you understand this material, okay? Because this is huge. All right. So I said there's no such thing as a sum of squares, but there is such a thing as a sum of cubes, even a difference of cubes. Okay, so sum of cubes and difference of cubes. That means both of these are like cubed pieces. This one would be like x cubed. This one would be 3 cubed. Okay, so 3 cubed is 27. So this is like saying a sum between two cubes. And this is the equation that you can do to get those pieces. Now, this is a little weird to memorize, but there is an acronym. It's called SOAP, where it's the same, and it's talking about signs, like the positive and negative signs, by the way. It's same, opposite, and always positive. So same, opposite, and like always positive. Let me show you what that means. So if I looked at this, and this was a positive here, it's the same. Let me do that better with colors. So the same sign, let's go with black. The opposite sign, which you see a negative, and then red. Always positive. So if this is positive, this is always positive, okay? But if it said a cubed minus b cubed, like up here, this would be a difference of cubes. Okay, so you have both of these. You have a sum and difference of cubes. You don't have a sum of squares. You only have a difference of squares. So the difference of cubes would be like this. Here we go. This first one has 2 terms. This one has 3 terms. This one has 2. This one has 3. Okay, here we go. The signs would be same, opposite. This was a negative, so this opposite would be a positive. And then it doesn't matter here, because this is always positive. Now we just got to figure out what are these 5 terms that I draw. So the first step is the square root of this first term. Okay, so it's like taking the square root of, the cubed root, because these are some cubes. The cubed root of this first term is just a. The cubed root of the second term, okay, so the second term is b cubed, would go to b. So SOAP took care of the signs. Second step, the square root of both terms and write it as the first binomial right here. And then the trinomial is the last step. It's built. This thing is built from whatever that is. So the first term, a squared. So whatever that term is right here, we're going to square it to get our first term in the trinomial. This b would be squared. And these can be numbers sometimes. It could be like 20, or it could be like 5. If it was 5 instead of b, I'd write it 25. If it was 3 instead of b, I would write it 9. Because again, all I'm doing is squaring each of these. And then the third step is just multiply these two together. So we get AB. Don't worry about positive A times negative B. Don't think about like that, because SOAP took care of our signs. Okay, so it's like we were washed our hands, pun intended, of signs, responsibilities. All we need to do is square root or square both terms and then multiply those to get that middle term. Now you're probably looking at this, some of you, and you probably feel like, shouldn't there be a 2 in front of the AB? Nope, because this is not the same as sum and difference of cubes. This came from something that looked like this. Okay, so if I were to FOIL this out, a plus b squared, it's like a plus b times a plus b. That would give me this. Okay, so from all this, I want to make sure that you understand. You have a sum of cubes, which is right here. You have a difference of cubes, which is right here. And then you have a difference of squares, like you could have difference between x squared and 9. And remember, this comes to x plus 3 and x minus 3. But you don't have a sum. Okay, the one that doesn't work, you don't have a sum of squares. Because again, there's no way that you can do this. And I've shown you many ways now. You can set it equal to 0, subtract the 9 over, and you see that it's going to be plus or minus 3i. Okay, it's going to be imaginary. It's not going to be real. Because again, if you were to try to even factor, I already showed you an example of that. This doesn't work out. It never crosses the x-axis. Okay, what looks like a sum of squares, this isn't a sum of squares. That's a multiplicity of 2. Okay, and over here, this is a difference of cubes, or sorry, difference of squares, because there's a difference, and these are square pieces. Okay, you don't look at it in parentheses form. You look at it already distributed out with no parentheses. That's how you determine. Just like this. This one didn't have parentheses, but it was a sum of cubes. Okay, just want to make sure that you understand that. Okay, let me see. All right, so then we will go ahead and look at this example here. We had x cubed plus 27. So it was the same, opposite, always positive. Step 2, take the cubed root of the first one to get that. Take the cube root of 27 to get 3. Third step, let's go with orange. We go from here, we square this first one. We square the last one, that's where that 9 comes from. And now just multiply these two. 3 times x, we get 3x. So it'll be the two factors are x plus 3 and x squared minus 3x plus 9. A binomial and a trinomial is how you do the sums or the difference of cubes. Okay, and from here, we could set this equal to 0, so that x is equal to a negative 3. Now, I know it didn't ask us to solve it out fully. It just wanted us to figure out the quadratic factor and the linear factor. But no worries, we're going to be doing this anyway, so might as well give this an example by showing you the work. So we have x plus 3 as one of the factors. Let me go ahead and write that out. X plus 3. And then we have the rest. We have x squared minus 3x plus 9. So the x plus 3, that's easy. Set it equal to 0. X is negative 3. That's our first real solution. No i's were involved. And then over here, I would look at it as the discriminant test just real quick to see if there's going to be imaginary solutions. And I would say b squared minus 4ac. So 4ac. And I would get 9, because negative 3 times negative 3 is a positive 9, minus 36. This is obviously negative. And because it's negative, it's going to be two imaginary solutions. So there's going to be i's involved. Okay, so because of that, remember this discriminant test, we highly tested it in the last unit. And a lot of people forgot it. A lot of people didn't use it. It's huge. You have to see it as far as to help you save time of when and where should you do a number sense trial and error factoring, when and where should you do factor by grouping, that A times C business, when you make 3 into 4, UGCF, what's inside parentheses is an answer, what's outside parentheses is the other answer. That was factor by grouping. Or you could just do quadratic formula. And to me, if I ever get a negative here, I just go straight to the quadratic formula. You have completing the square. There's many different things that you can do. Remember, we can't relearn the last unit. You're expected to remember and know all that stuff. So let's go ahead and go negative b plus or minus the square root in this new factored form of parentheses. These parentheses are huge. This is where a lot of people make mistakes into calc. So negative b plus or minus the square root of b squared minus 4ac. So a was 1, c was 9. Again, the reason why we do the discriminant test is right here we know 9 minus 36. We already know it's going to be a negative something, okay? So what, a negative 27? This negative 3 is still a positive, and it's all over 2a, okay? So it's all over 2 times 1. And then now you're just going to figure it out as far as, remember, it's no longer a cubed root. This is x to the power of 1, and this is x squared to the power of 1, but it's still x squared. So when I take this square root, don't think like you're going to take the cubed root of 27 and get 3. It's not that. It's a square root, okay? So let's break up that into this. So negative 27, we broke up into that. So we need the 9 is going to come out. Okay, it's going to come out as a 3. And this negative 1 comes out as an I. And that 3 stays inside. Okay, so it's going to be this 3, I'll write that right here, plus or minus this stuff all over 2. Okay, and you can leave it like this because this 3 and 2 do not reduce, and neither does this 3 nor this 2. So we would have 3 plus 3i root 3 over 2, and 3 minus 3i root 3 over 2. And your third and final one was that x is equal to negative 3. A little bit of extra work, but I want to make sure that you are understanding as far as how far it went down. What are the linear and quadratic factors for the following? Okay, look at this. This is a sum of cubes. The 8 can be written as a 2 cubed. The x can be written as an x cubed. And this 125 can be written as a 5 cubed. Because 5 times 5 is 25, times 5 more is 125. Okay, so here we go. The steps would include writing this out as far as 2 and 3. So binomial and a trinomial. This is a positive, so same, opposite, always positive. Step 2. What's the cubed root of all of these terms? 8 goes down to 2, x goes down to x, so 2x for the first one, 5 for the second. Square this, you get 4x squared. Square this to get 25, and now multiply 2x times 5 is 2x, or 10x. And that's how we got that piece right there. So the linear factor means it's to the power of 1 is 2x plus 5. And the quadratic factor, which means this x squared, yes, it's to the power of 1 here, but it still simplifies out to an x squared term, which is right here. All that is the quadratic factor. I won't continue to work that one out because we will do more of those in class for sure. I want to not make this video too super long because we have still some example problems to do. We have 4 more example problems, and then I will record the other one on a different video. All right, so let's go ahead and go to what are the linear and quadratic functions here. So never did it say to solve anything. It's looking at expressions because there's no equal sign or no equal 0. So we're just going to GCF out what they have in common. They both have a 3. They both have at least one x. So you pull that out. So if you pulled out a 3x from both pieces, this would become x cubed. That simplifies to 1. You have 4 up top, 1 on the bottom. Who wins? The top by 3. The other one that you would have is this 3x here. Remember, you were GCFing out this 3x. So it would divide, cancel to 1, and then you just have this negative here. That's how you pulled it out from both pieces. And now this, look at that. You have a 3x as one of your factors. You have a difference of cubes, okay? So again, this, you have to remember these rules. There's a lot to remember, guys. So the cubed root of x cubed is just x, okay? Again, sum of cubes and difference of cubes, you have to look at both of these terms and you have to cube root them. That means backwards, break them down. This would go to x. What's the cube root? So what times itself 3 times would give you x cubed? Is what this right here means. Well, that would be x. So that's why I wrote an x right here. Okay? The cube root of 1 is just 1. And here we go. Our original problem was, our difference of cubes started as a negative, so to be the same, opposite, always positive. We're almost done. Square this piece to get x squared, square this piece to get 1. Now multiply these two to get 1 times x, and those are the factors. The linear factor is x minus 1, and then the quadratic is this x squared plus x plus 1. And we will not continue to solve those out because this is just helping you identify which ones are linear, which ones are quadratic. Okay, so remember how we, with factor by grouping, we had 3 terms, we broke them into 2, and then we GCF paired them out. Well, when you have 4 that you GCF, here's what I'm going to say. It's a really good idea to, your first go-to when you see 4 is to try to see, first of course, GCF, but second, can I pair these two? So 9 out of 10 times when you see 4 here, not 3, because when you see 3 terms, you know that it just becomes 2 binomials for the most part. But when you see 4 terms, I want you to pair them up like this. The GCF in the front, this first one is x cubed. If you divide x cubed from both of them, the leftover scraps are x plus 3, which is what you see right here. Okay? And then you look at the other two, and what do they have in common, GCF-wise? Well, you can pull out an x from both of them, which is right here. And what scraps are left? Well, if I pulled out an x would be left over. If I pulled out an x, 3 would be left over, which is what you see here. Okay? Now remember, this is factor by grouping. What's outside of the parentheses is one of your factors. What's inside should be the same. Carbon copy. If it's not, it's wrong. Will be your other factor. Okay? So now, notice what we can also do. I can pull out even further an x. So that this would reduce to x squared plus 1. So this is our most factored piece. How do I know to stop there? Because it's x to the 1, parentheses to the 1, parentheses to the 1. And we've talked about that last class. Okay? So from here, the linear factors are x, because it's x to the 1, and x plus 3, because it's to the power of 1. That's linear. Quadratic is like x squared. There's an x squared. Even though this is 1, it will become quadratic nonetheless. And that's your quadratic factor. And yes, you would set them equal to 0 if it asks you to do that and solve for 1. each one independently. We have 2 more guys in this long video, okay? Here we go. What are the linear and quadratic factors of a polynomial? Is this the same? X cubed plus 3x squared. No, this one's a different one. Okay, here we go. So we can, again, group the first 2 together and the last 2 together, pull out a GCF, which in this case was x squared, and I get an x plus 3 left over from that. Color coordinating this, the second factor, if I pull it out, is 16, negative 16 that is, a positive x, positive 3 would be left over. There's multiplication, there's multiplication. 1, 2 terms. Again, when it's all multiplied together, 1 term. If there's any addition or subtracting, separating islands, you have to count each piece. So 1 term here and 1 term there. So you have 2 terms. Okay, so now from here, you can see that what's inside the parentheses is 1 factor, and what's outside of the parentheses is another factor. This is what I've been telling you guys. This is why I offered the pizza party, which again, 7th period 1, and I'm not going to forget, I'm going to have that for next class. Last unit was so big because it built so much on this unit. If you didn't learn last unit, you'd be totally lost on this unit. So this difference of squares becomes plus or minus 4. And this one, that's a x plus 3 all by itself. It just factors down to x plus 3, still the same. And if I asked you, which I didn't, but if I did, what are the zeros? You'd say negative 4, 4, and negative 3. Our last example problem. What are the real or imaginary solutions of this thing here? There's a lot going on there. So this says I need to set it equal to something and solve for x. Well, we've been setting it equal to 0 with doing quadratics and all these polynomials, and we're going to continue to do that. So I'm going to move this over either to the left or move this to the right. A lot of times you like to see x equals something, so chances are it's probably more common for you to move everything to the left. So we subtract it. Notice this, we subtract this to the left. It used to be a positive when it was on the right side. But when you move it, it has to be a subtraction, okay? And then we distribute those pieces to get negative 8x minus 8. Excuse me, it's a little late right now and I'm sleepy. And then you could distribute this one to get x cubed plus 8x. The only reason why I distributed that is so I can combine like terms, and you see that that goes away, and you're left with the difference of cubes. Here we go. Difference of cubes, you have 2 and 3 terms. This is going to be the same, opposite, always positive. Last example problem. The cube root of x cubed is x. The cube root of 8 is 2. And the next step you would do is you would square the first one to get x squared. Square the last one to get 4. And then just multiply those 2 together to get 2x. This is how we got this step here. And yes, if you were to solve it out, you could see right here, setting this quadratic equal to 0, you would have imaginary solutions. And then the other answer is just 2. Okay, so these imaginary solutions here became imaginary down here. And the reason why they're imaginary is because I could have seen right here in this form that the discriminant test, again, is so important, of b squared minus 4a, c. 2 squared is 4, negative 4, 1, and 4, or negative 16. This is a negative 12, obviously as negative. And because it's negative, it never goes through the x-axis. and you will have imaginary roots. That's why we choose to do the quadratic formula. Otherwise, you're doing quadratic formula every single problem, and it's annoying, it takes forever, and it's not efficient. But these would result as your imaginary solutions when you look at all this work and simplify. All right, guys, that's and you will have homework. I will post homework. This is a video. This is a video for sure, an hour and 15 minutes long. So pretty much all of the period, you were just taking notes. I think what I'm going to end up doing after all is that boxed activity and the box project. I will wait until next class to do, because this is super, super important what I just recorded. Take it home, rewatch it, do whatever you need to do as far as to understand. Ask questions early. If you have questions, text them through mine. You can ask me in class, but nonetheless, the homework is still going to be due whenever it says it on the calendar, and I will post that tomorrow for sure. Okay, so for A day, it's going to be due on Wednesday, and for B day, it would be due on Thursday. But I'm going to be there for B day, so you will see all of this in class, but nonetheless, you're responsible for both, and this video is there in case you need it. Okay, so I look forward to seeing you guys next class. Y'all have an awesome day.